So next, let's try to study the intensity of EM waves. In the chapter 14, we already defined what is intensity. Intensity is just the energy carried by a wave, and the energy will be delivered to an area within certain period of time. And this is a definition of intensity. So the same definition is applied here. So let's try to use these pictures. So if you have the screen, and now you have the source produce the light. So the light will hit on this area with cross-section area A, and the total time the light hit on is delta T. So in that case, the intensity is defined in terms of the total energy delivered to this area for this particular area with certain period of time. So this definition is just borrowed from this statement here. However, now we are studying about the EM waves. So we just learned how to calculate the energy density carried by the electric and magnetic fields. So therefore, the total energy density is known, which is the U, which is the summation of the two terms. However, energy density is not energy. So the energy is the energy density multiplied by the area, or the volume, I should say, the volume. So we know that the light will propagate from the source and hits on the cross-section area here, and the total time last is delta T. So therefore, the volume here is the cross-section area multiplied by the distance from the source to the cross-section area. And what is the distance here? So the distance here is the speed of light multiplied by the time. So this is the distance and multiplied by area, so this is the volume. And now you know that the total energy density. So therefore, U multiplied by V is the total energy delivered to the area. And now you both have the A in the numerator and the denominators. So these two terms cancel out. And you both has the delta T there. So delta T also cancel out. So now this term will become simply just the energy density of the EM wave multiplied by the speed of light. But the last equation here, people will feel a little bit confused. I say that the intensity now is power divided by the area. So it is hard to see that power divided by area is equivalent to U times C. But this one is simply from the definition here. So how do we define the power? Power is the energy given within certain period of time. So which means the energy given within certain period of time is a power. Therefore, delta U divided by delta T is actually the power, the definition of power. So this reason you can also rewrite its intensity in terms of power divided by the area. So this is a very useful and a very important result for the lecture today. So make sure you know that how to get from this first equation to the second, third, and the third, fourth, and the fifth one. Make sure they are all connected, and they are just a different expression of the same quantity, which is the intensity. So now let's try to use the thing we studied before, then combine them all together. So I just show you that the intensity is actually the energy density multiplied by C. And because you know that the total energy density is a combination of the electric field and B field, but now you should use the rule mean square. Don't forget about that. But now multiply each the term by the C, okay? And because we claim that if this value is root mean square, so ideally this term should be the same as this term. So the intensity can also be expressed in terms of the C multiplied by the epsilon naught multiplied by the E square, or C divided by the mu naught multiplied by the B squared. So here U stands for the total energy density. Now let's take a look about this one. So if you have an EM wave, so if you have energy, then definitely you will carry the momentum. So the momentum carried by the EM wave, if you check the result we derived in the previous semester, the relation between the total energy and the momentum is simply the total energy divided by the velocity. However, now the velocity of the EM wave is c, the speed of light. So now it is the total energy divided by c, which is the momentum. And what is the total energy? This is what we just used before, yeah? The energy density multiplied by the volume. So therefore, now you can try to use the result here. The intensity is simply the energy density multiplied by C. So U average multiplied by C is replaced by this intensity average. So now this is the relation between the momentum and the intensity. Now, this momentum carried by the EM wave will interact with the screen I just showed you. So the EM wave will carry the momentum and hit on that. So there is a difference of the momentum. So originally you have this value, but final momentum will become 0. So that's the reason I write down delta P here. Intrinsically it is a P minus 0. So all the momentum will be given. So if you remember that result also from our previous semester, if you change the momentum, you will create a force, which is F average. So change of the pressure will cause a force on the area, which acting on by the EM wave. So what is the average force? It is the change of the momentum with respect to time. So now there are two different kind of concepts. So here, this is the pressure. Yeah? So pressure is the force divided by A. And the average force is the difference of momentum divided by delta T. So don't confuse the delta P here and the pressure here. And now because you know the delta P can be expressed in terms of this. So if you substitute this formula into this relation, then you will get that the pressure exerted by the EM wave on the cross-section area A is actually related to the intensity of the EM wave divided by the speed of light. So now let's try to connect all the three important physics quantities here. So first, the intensity of the EM wave is expressed in terms of the energy density multiplied by the speed of light. The second one is the momentum carried by the EM wave. So the momentum is related to the total energy divided by C, but now, eventually, they can be rewritten in terms of the intensity. So intensity of the EM wave, now the momentum. And finally, there is the pressure exerted on the cross-section area A, and the average pressure is also can be expressed in terms of the intensity divided by the speed of light. So 1, 2, 3 variable, and the rest of 2 can be all expressed in terms of the intensity. So now let me give you examples. So now within the garage, and the only light source you have is the light bulb here. Okay. So they are asking about at a distance r, which is 1.0 away from the light source. And if the average power is 50 watts produced by the light source, then at a distance r equal to 1 meter, what is the average intensity of the light? And then what is the RMS root mean square value of the electric field and the B field? So here they also say you should assume that 5% of the electric power consumed by the bulb is converted to the light. So here I only give you the power produced by the light bulb, but only 5% of the power was given to the light. Okay? So now let's try to solve the problem A. What is the very average intensity of the light? So from the previous equation, you know that the intensity, average intensity, can be expressed in terms of the power divided by the area. So in case you forgot this one, so let me go back to the slide. So intensity is equivalent to the power of the EM wave divided by the cross-section area. So don't forget about that one. So therefore, the average intensity is the average of the power divided by the cross-section area. However, you cannot simply use the 50 watt because only 5% of the 50 watt was converted to the light. So the average power is 50 watt multiplied by 0.05 and divided by the area. So what is the area? So the energy will spread out evenly, equally distributed around the spherical surface here. So the cross-section area of the spherical surface is the 4 pi r squared. So the energy will spread out evenly on that. So therefore, the average intensity is 0.199. And the problem 2 wants you to solve for the root mean square of the electric field. And we also learned that the average intensity can be expressed in terms of the C multiplied by epsilon naught multiplied by the root mean square of the electric field square. So in case you forgot that, let's go back and refresh the memory. So the intensity is actually the C multiplied by epsilon naught multiplied by the E root mean square and the square. So therefore, if you use this formula, then you can calculate the root mean square of the electric field, and this is the value. And now, not a surprise to you, if you try to calculate the root mean square of the B field, you still use the same equation, but now it is in terms of the B field. So therefore, the root mean square of the B field is this value.